this computer. So welcome to our CCNP class. Can everybody see my Canvas class?
Yeah.
Okay. So I'm going to pull up this. I just added this as one document I've added into our class, and I will be continually updating it. But what I've done is I've gone in and taken the CCNP blueprint, and I've gone in and I've started putting in for you where you can find this information. So section 1.7, where we need to learn how to differentiate between process, fast switching, and Ceph, and MAC address table and the TCAM table, and then fibs and ribs, so the 40 information base and the routing information base. That is in chapters 1 through 5, and in fact, it's in chapter 1, I do believe, 1 or 2. So I put that in there. I've also gone down, and we've got down here. Oh, where was that? I may have already missed it. Nope, it's a little further down. Here it is. Today, we're going to be talking a great deal about this. So troubleshooting static and dynamic trunking protocols. We're really just, instead of troubleshooting, we're going to be configuring them and talking about some issues that can happen with that. Troubleshooting static and dynamic ether channels. Notice it's not saying configure, it's saying troubleshooting, which is very interesting. But then we are going to talk about configuring and verifying common spanning tree protocols, RSTP and MST. MST in particular is one we're going to talk about because we have not done that one in the past at all. So we're going to actually configure it and show you MST running in an environment. I want to make sure you're reading this blueprint closely, because you will notice that, for instance, if you search this blueprint, pretty much the only thing you see on EIGRP is that, and that is compare routing concepts of EIGRP, so advanced distance vector, versus link state, OSPF. You'll notice it doesn't even talk about configuring EIGRP. Now, we have labs on NetLabs configuring EIGRP, and it's a good idea to do those labs. But as far as configuration goes, configuring OSPF is what we need to think about when we get into actually configuring. But you also notice it just configures simple OSPF environments, including multiple normal areas, summarization, and filtering. It does not get into any kind of craziness in OSPF with massive multi-areas. And also look at BGP. Configure and verify external BGP connectivity between directly connected neighbors, best path selection algorithm, and neighbor relationships. So there's a lot in the book about communities and about, there's just a lot more detail on BGP in the book than what is needed for this exam. So I have been overwhelmed preparing for this exam because there's so much in that book that I felt like the exam was almost not passable. But as I've continued to go through here and look at this, more and more I am focusing on what is in this blueprint and what is needed for the blueprint, and not trying to go a huge way outside of that. So just want to throw that out there because I think that is important for you as you look at that book. Follow this blueprint, follow the chapters I give you, and just learn, you know, I hate to say it, you can learn all of it, which is good, but for the exam right now, learn what's in this blueprint, and then you'll be able to move on. And when we get to NARSI, yes, we're going to dig deeper, and we'll be coming back to some of the stuff that's in the book, but it's not stuff that's necessarily needed right now for the CCNP ENCORE. I've also placed into our class, again, a little set of notes on MST. So this is some things I pulled out of not only that training I have, but just some things on how to do configurations, talking about your region names, talking about instances and the revisions, and how to do some of the basic things that are associated with MST. Okay. Now, what I want to do today is not that. I didn't want to minimize all of my stuff. Go back in here and pull up. Where was it? Oh, my notepad. There it is. All right. So what we're going to do, first off, folks, this is Cisco Modeling Labs. It has the ability for you to create and add in all different types of devices into a virtualized environment. It's not simulation, which is a very important thing. This is the actual iOS images. They're just being virtualized inside of Cisco Modeling Labs. So you can see all the different items that are available here, from a Cisco 9000 XRV, which can take up an enormous amount of processing power, because notice it says at least 20 gigs and 4 vCPUs to run that. So be aware that if you put that over here and boot it, it's probably going to crash my system, or at least very much slow it down. This is the personal edition, which you can buy for around $200. But there's also a Cisco education version that we will be loading here shortly, that I'm going to give all of you access to, and you'll be able to play with. But what I did is I went in and grabbed 2 different switches. They're just 2 layer 2 switches. And between these 2 switches, I have connected 2 different gigabit interfaces, gigabit 00 to 00 and 01 to 01. So they're very simple. It's a very simple design, nothing crazy about it. Now, one of the things, got a question? Somebody got a question? Again, one of the things I want to show you that's really cool is on the links, you can go into the link and you can actually simulate bandwidth, latency, jitter, and loss. So you can actually apply a percentage loss across these to see what would happen to a link. You can do that on a per link basis. And you can also do packet captures directly from inside of here. So when we start moving some traffic across, we will see right now we're getting STP packets coming across. So we can actually see a built-in packet capture tool inside of this Cisco Modeling Labs, which is really neat. And then you can actually download them as a PCAP file, and you can look at them inside of Wireshark or TSpeedDump or other items if you want to look at them later. But what we're going to do right now is we're going to go into switch 1. And what I want to do is looking at different concepts of, if I click on the right thing, the different concepts in these first couple chapters, and some of the things that we're trying to do. I quit that. There we go. What are you doing? Let me minimize this and see if I can. All right. So we are going to look at switch 1, and we are, I said I was. Okay. Can y'all still hear me?
I can hear you.
Okay. My Cisco Modeling Labs just went non-responsive. All right, give me a second to fix this. 1096. This is what happens when you do things live. Let's try again. Okay. I'm going to delete that one so it's just gone, so it's not causing any issues. Nodes. All right. I pulled it too far up. There we go. By the way, you also can build initial boot ups and nodes. Let me do this. I don't know why this is doing this, folks. All right. Well, there's always more than one way to skin a cat. So what we're going to do is we're going to wipe this. I'm going to delete it. And we're just going to build a new one. So we're going to pull out an iOS 2, and we're going to connect our interfaces, gig 00 to gig 00, and gig 01 to gig 01. And then we're going to go back out to our dashboard and boot it. And now we should be able to watch these eventually boot once they get up and running. So the lab should be starting now. You'll see this little circular circle. That means that the device is booting up. Yep, of course, like I said, it's worked great all day, and now it's I'm trying to do the lab, it's not won't work. Tell you what I'm gonna do. Give me just a second. I'll let y'all in. Here we're gonna do Wizard of Oz. This is the VM that's running, that's supporting CML in the background. It's been up for several weeks, so I'm just gonna power this thing off, and I'll power it back up, and we'll see if we can't get it to fix it. So I've had it on for, oh god, it's been 2 weeks now on my machine, so there's a good chance that it just decided that it needed a reboot. And just so I can be ensuring that if this doesn't work, I have a backup to my backup. I'm gonna go on out here to Nick, you're doing MST now. I'll go ahead and go grab the other pod and get it. Come on, shut down.
Say if I need to get out, let me know.
No, actually, you know what? I can probably just jump in yours since you've already got it up and running. The only thing I don't have here is I don't have 2 links between D1 and D2, but that's okay. Nick, you mind if I grab your pod here?
Go for it.
All right, let's go ahead. And, have you done any config on it?
Just the initial config that you sent in the files.
Okay, so the VLANs are there. Let's see if I was going to turn on VTP. So as we look on what I was wanting to kind of talk about today, man, yeah, I really do have something funky going on. I was going to talk about VLANs and trunks. First off, I don't really think I need to spend a whole lot of time talking about VLANs or how to create a VLAN. So obviously show VLAN shows that with the default config, we've got 2nd, 3rd, 4th, and 5th VLANs created. If I do a show VTP status, which is our VLAN trunking protocol, you'll see that it is currently no domain name. We are running in server mode, and we're at configuration version 4. So what I'm going to do is, looking at our topologies, I'm just going to focus on D1 and A1, and I'm going to create first a set of trunks between D1 and A1. So let's remember that's 105, 106 on D1. So let's go in here and do config T and go interface range G105 to 6. And I need another slash in there. Okay. Now I'm going to go ahead and make these trunks. Now this is important when we talk about VTP, because VTP stands for VLAN trunking protocol. So if you don't have a trunk between your 2 devices, VTP cannot work. So let's go ahead and do switch port mode trunk. Switch port trunk. You don't have to do encap. That's really all we had to do. We don't have to do allowed VLANs. We don't have to do anything else. We can just let it do default. By default, when you do switch port mode trunk, what VLANs are allowed? Anybody remember? By default, all of them are allowed. So if you do show int trunk, anytime a trunk is set up, by default, all VLANs are allowed, 1 through 4094. By default, the native VLAN is 99. That's the kind of thing you really want to kind of get in your stored in your brain there. Also, this 8021Q encapsulation, with the switches we use in our labs, the only encapsulation available is .1Q. Out in the real world, and also like in Cisco modeling labs, you actually have to set the encapsulation to .1Q because the switches do support ISL, which is an old method. So we've set up really on the D1, we've set trunking up on our gig 105, gig 106. So let's go to A1. Let's go to int range FA01. Rainfart 0102, yep, 0102. And let's go to switch port mode trunk. And then we'll do show int trunk, which that's show int trunks what I use 99.9% of the time. You'll see that we are trunking on 01 and 02. So now that we have a trunk between these two, what I can do now, if I do show VLAN, we've copied in these, the second, third, fourth, and fifth, but I'm gonna go back to D1 and let's configure VTP. So we're gonna first set our VTP domain. We'll just say Cisco. We'll say VTP, and if we wanted to, we could set our version number up to 3. Let's go ahead and make it version 3. And then we're gonna do a VTP password and make it Cisco 123. All right. And then at this point, I should be able to go over here to A1 and let's make A1. We're going to exit back here one time. VTP mode client. VTP domain Cisco. VTP password Cisco 123. Then we'll do show VTP status. And you'll see that we are, I know what I forgot. Guess what I forgot? VTP version 3. So then show our status. So we're running version 3. Our domain name is Cisco. We are a client, okay? And number of existing VLANs are 9. And so that's what we got to know here. So what we're going to do is we're going to go right here and do a do show VLAN. And you'll see that we've got 2, 3, 4, and 5, but we're going to go now to D1, do show VLAN, and we should have 2, 3, 4, and 5, but we're going to add some VLANs here. So we're going to do VLAN 10 name. Oh, okay, so we're not the primary, so let's do VTP mode server. And VLAN 10. Okay, I know what's going on. The D2 is causing issues. So let's go over here and just shut down the interfaces on D2. Gig 101. /0/1. So we're just going to basically remove D2 from the topology 10506. All right, so it's gone. So we got rid of it. So let's see if it now will let us do it. Nope. Okay, so what we've got to do is do show VTP status.
Should you be primary server?
Yeah, I might be able to do that. Okay. Let's see if it's caused by that. All right, well, let's do this. VLAN 1. I'll go ahead and tell you, I've never seen this message in my life.
I got it when I was doing these.
Did you?
Yeah.
I've never seen it. Well, how'd you fix it? You said VTP.
I thought it was a primary server because it's talking about being a primary server, but
Yeah.
let me go back. Let me go back and
VTP,
look at what I did.
domain. Let's do this. I got an idea. Class Vtp domain. We can move it out of this. Vtp domain back to Cisco.
Kelly,
Yeah.
are you trying to make D2 not see, like you want to put a bunch of VLANs on it and show us that they don't propagate?
No, I want them to, I'm trying to make them propagate.
Oh, on D2. Oh, okay.
Correct. Well, actually on the A1. Over on the A1 because A1 is my client. All right, let me. Okay, so Vtp primary.
I got it to work last night when I shut and unshut the links to A1. So because I don't know, the timers weren't working or something, but when I took the links down and brought them back up, then it just took I guess about 30 seconds and they propagated from D1 to A1.
I see what it is. I see what it is. Okay, here's what's happened. VTP, okay. VTP expects that you're going to set VTP up before you create VLANs. So what we have here is we have a switch that already has, if I do a do-dir, we have a VLAN.dat in here. Okay, so there's a VLAN.dat already existing. So VTP is not associated with that particular the VLANs that have already been created. So that we've created. VTP doesn't understand them, doesn't know them.
If you need to rerun the tickle script,
it's actually also a result of VTP version 3. So let's do this. VTP version 2 will fix the issue. It's a function of version 3 version 3 lets you set it on a per even spanning tree version. So it's a function of being version 3. So let's just change to that and that'll just make life a lot easier for us. But if we had wanted to run version 3, the proper way to do this is, number one, have no VLANs on your switch before you configure VTP, then use VTP version 3 and then create your VLANs. And when you do, you will then be the recipient of the VLANs. So let's see if we can do this here. I'm gonna VLAN 20, name manage, VLAN 30, name students, and then Control Z. All right. So one of the things I do want to show you, and I think I showed you this before, but this is where packet tracer will get you in trouble. Do show VLAN. Notice how I've got my VLAN 102030 in here, but if I go in here and I do a VLAN 40 name test, all right, and now do show VLAN, notice how 40 is not in here yet. And that is because the way real iOS images work, until you exit from the config-VLAN, if I can type exit, do show VLAN, until you exit from there, it's not written into the VLAN.dat file. However, inside of Packet Tracer, the second you create a VLAN, it writes it into the VLAN.dat file in Packet Tracer. So be aware that's a difference between real world and Packet Tracer world. All right, so now let's see if we've actually got show IPM brief. So 0102 should be up. Let's do a show int trunk. It's up. And show VLAN. Aha. Okay. So you will see we have our VLANs are being propagated because Vtp status. We are part of the domain name Cisco. We are running version 2. Again, the reason we had trouble is because with version 3, you had to make sure there are no created VLANs before you use version 3. This is a client. Now, one of the other things you can do, show Vtp password. This is a command a lot of people don't know about, but it will show you your actual password that's configured. But now we go over here and do show Vtp status. And we can see that this is our server. And any VLAN we create over here and Control Z it, will get propagated over to A1. Okay, there's yet another VLAN. So VLAN trunking protocol requires a couple things. One, you got to have trunks. Two, once you set your VLANs up, the VLANs will be propagated from your servers to your clients. Now, what's the other mode that can be used in VTP? You've got servers, clients, and
Transparent.
transparent. And transparent is for a switch that will not participate in VTP, but could let VTP information pass through it. All right, which would be rare that we would use that. One of the things about VTP to be very careful with is this right here. And that's when I do a show VTP status. You see my revision number, okay, 5. What happens and has happened in the real world is this. Imagine that you're running a lab and you're using the actual name of the VTP domain for your campus network, but you're running a test environment. You take a switch. It's got the real name for the VTP. It's got the real password. You've created a couple hundred VLANs on it. And so its revision is up at 20. You then hook that particular switch into your campus network, and it suddenly overwrites every VLAN on your entire campus network. That has happened in the real world. Okay. That is why anytime you have a switch that you're putting into your network, you make absolutely sure that the entire configuration is deleted and that it is not configured with VTP any way, shape, form related to what is in your network. Does that make sense?
Yeah.
Okay. Any questions on trunk links or on VTP? All right. Let me bounce back over and see if I can possibly get CML back up and running.
Gilly, I did have a question back there
Okay.
at show VTP status.
Okay.
What is that MD5 hash about?
It is actually the hash of the should be the hash of the password.
Oh, okay. Okay.
Should be the hash of the password. I do believe that is correct.
Thank you.
Mm-hmm. I'll look that up and make sure I'm right, but I think that is correct. All right, now let's see if we can try this again. Let's boot this one. Michelle, it actually is the password and the domain name together. So it is those two being hashed together to get that hash, it looks like.
Okay, thanks.
Mm-hmm. I knew it had the password in it, but I didn't know. All right, it's still booting, so let's let it boot. It's kind of neat. It should say, what is happening there? All right, I'm not gonna work with it. I'm just gonna keep going over here. Okay, so we've got our VTP set up between D1 and A1. So now let's set us up a port channel. Now, what is a port channel? In fact, we're not going to be able to set a port channel up. Somebody tell me why. Why can I not set port channels up in this lab between D2 or D1 and A1?
You have gigabits and fast Ethernet.
Exactly. Exactly. In order for port channels to match or to work, to create, first off, what is a port channel? Sometimes you'll hear it called aggregation. All right. So it's the bundling of multiple links together. It's when we bundle links together. But to do that, they have to match some very specific requirements. Those requirements are, there has to be the same speed, same duplex, They have to support the same VLANs. They have to be in the same mode, which is kind of weird, but you can actually have port channels that are layer 3 or layer 2. So L2 or L3 ports. Get my OneNote up now. Pull the rest of my little notes on it. So for an Ether channel to be put together, it has to meet these requirements right here. So it has to be same speed and duplex, same mode, access or trunk, same native and allowed VLANs if they are trunk ports, and same access VLAN on access ports if it's an access port. I am stumped on this one. It looks like my, you know what? Let me see. See, my licensing's gone out. Nope. That's so aggravating because it worked so well when I was doing it in my thing. Okay. So we won't be able to show you an actual port channel being created. There's a lab on it, so you can do the lab on the port channels. When you troubleshoot port channels, one of the things is a very important command is show ether channel summary. Okay, which is very important. Let you see that. You also can do show ether channel number and then the detail to get details on it. It's important to know that a lot of times the biggest issues are one port may be in a different mode than the other. Remember, we have two dynamic protocols that can be used for creating ether channels, and that is LACP and PageP. Which one is Cisco proprietary?
PageP.
PageP, yep. With LACP, you have two different modes that you can set the interfaces on, active or passive. All right. Remember that by A and P, okay, active and passive. Active means it will actually attempt to become a channel, a LACP channel. So it's going to attempt. Passive, it will become one, will become LACP if it sees active on the other side, basically. Now, PageP has its two modes, which are auto and desirable. Okay, and auto attempts to become, and desirable is it will be if it is if it sees traffic from the other side. Okay, so in auto mode, it passively negotiates. Okay, so if it's auto, so this is a passive mode here for it. It's a passive mode. Desirable, it actively tries to become a PageP link. All right. There is one other mode, and that's simply on. So if you just do port channel and you say port channel group 1 mode on, it just becomes a port channel. It doesn't use LACP or PageP. The problem is if you do that on one side and not on the other, you can end up with issues. So I could technically create a port channel right here between D1 and D2. In fact, I will do that. So let's go int, although it's just one, G101. Let's do a no shut, exit, and let's go back over here. So 101 on D1, we're going to go in here and we're going to go config T, int 1 gig 101. Man, I can't type. And we're going to do channel group 1 mode, and then see here you can see whether you're active, auto, desirable, on, or passive. So I'm just going to say active on this side. Then we can go into our port channel 1, and that's our new interface. And you'll notice it doesn't look like I changed anywhere, but I did. I'm now in the port channel 1 interface. And I'm going to do switch port mode trunk. That's really all I had to do there. Let's go back to D1 now. We're going to go to int G101. We're going to do channel group 1 mode. Now we could do active or we could do passive on this side. So let's just do passive. Okay. Then we'll do int port channel 1. And we'll do switch port mode trunk. Now if we do a do show int trunk, there's no trunk yet. You want suspended likely not currently enabled on the remote port. There it goes. It finally come back up. There it goes. So now if I drop out, I can do a show ether channel summary. And you'll see that we have a port channel. Now it's kind of a dumb port channel because it's a single link. So typically we would have more than one link here. I will tell you some important items on port channels that I've been learning about. Is this. Port channels do load balance across the links, and by default the port channel load balance is, it depends on the switch you're using, but it's typically set up either channel detail. Okay, so max ports, actually we can do it like this too. We can do show run and see. Should be right at the top here. It was at the top of my other switch. Okay, hold on a second. Let's do this. Sure. Show ether channel statistics. You're not type. Nope, not summary. Did it again. Channel 1. Should show us. All right, give me just a second, folks. I've got to find my command that shows me this. Anybody remember the command that shows us our load balance method?
No.
On my other versions, it showed it at the top of the in the running config. But this iOS version is not doing that. It actually showed it right here when I turned on port channels. But this is not showing it. Folks, can you give me 1 second? I need to run out of the office for just a second. Sorry, be right back.
Really?
Resume recording. Yeah. Did you find it?
Yeah, try show ether channel load dash balance.
That's too easy. Yep, there it is. Source MAC. Okay. Now here's the funny thing. Most of the reading you will do in the book will tell you that destination source IP is the most common method used for load balancing. The reason I mention this is if you have 2 links, the load balance method would be based upon source MAC. So it's going to balance. Between the 2 based on the source MAC addresses of the incoming packets. If you have 3 links, it will not even use the third link for load balancing, because load balancing only works in variables of 2. So 2, 4, 6, 8. If you have, so think, just be aware of that. If you think that you're going to increase the ability for your switches to move information across, if you actually put in 3 links, 2 of them would be used for load balancing, and then 1 would be there as a redundant link, but it would not be used for load balancing. So you really need to think about, when you're doing your port channels, do them in groups of 2 to ensure that load balancing is important. And actually, you can set, I will tell you this, ether channel, actually
Port channel.
Load balance. You can set your method at the global here. So source destination IP, this one is the one that I've seen is the most common among Cisco devices. This destination IP is what ours is currently set to. If you change this load balance method on one side of your port channel, make absolutely sure you set it, you change it on the other side. In fact, that should bring our port channel down if I change it. So let's do source destination IP, and that should break our port channel. So we should see do show ether channel summary. So ether channel. It's still up right now, so I'm kind of surprised because that should break. So source destination IP, and it may be that we hadn't had any traffic go by, so source MAC. That should eventually break our port channel. And it may be, since we don't have any actual traffic going across here to load balance based upon that, it's not breaking anything at this point. But let's set them to the same on both sides. That way we don't have to worry about it going down. So port channel, load balance, source, destination, output. Yeah. So we know our command now is show ether channel load balance. One time it actually makes sense. So source destination IP here, source destination IP here. So that is how you can change it. Questions about ether channels? All right. I am going to do a show in trunk. Let's see if my trunk come up. Yep, we're good there. So I'm actually going to do VTP domain Cisco config T, VTP domain Cisco, VTP mode server, VTP mode, VTP password Cisco 123, VTP version 2. We show VLAN. Let's see if I got my VLANs from over there. We should eventually get them. We may actually have to create a VLAN on the other side to get it to come across, because of the fact that sometimes you have to change the. Okay. It may have been what this may fix it. Config T VLAN 200 VTP up. So we get it down here first. Yep, we got that there. Get it here. Yep, there goes. Okay, so now VTP is running between D1 and D2. If we go in here and do a show spanning tree, now what is the purpose of spanning tree?
To prevent loops in your network.
Yep, exactly, to prevent loops. The problem with spanning tree, if you will notice, every VLAN that we have created on this switch has created an instance of spanning tree. So you'll see every single one of these. There's 40, there's 100, there's 200. So every single one of them has created its own spanning tree instance, which means that in networks with very large numbers of VLANs, our number of spanning trees can be rather excessive. So what has been developed is multiple spanning tree, which is the ability to take and place VLANs into an instance of MST and have all of them appear to be one spanning tree. So we're going to group them together as a spanning tree. So with MST, what we're going to do is first off, change the mode on all devices in this network to MST. So we're going to go to global config, okay, and we'll go spanning tree mode MST. All right. If you ever want to see what other modes are supported, you can go in here and look. MST, PVST, and rapid PVST are what are supported on these particular switches. So one thing I would suggest is always make sure all devices in your network, well, I can't say that. If you can't have actual MST domains or areas that, and in some of your network runs regular spanning trees, so maybe PVST, PVST plus, another runs MST. But for our simplicity's sake, we're going to make everything MST. Now what we're going to do is this. We've got it set to MST. So if I do a show spanning tree, you will see that we're running MSTP. And right now, instance 0, we've only got one instance, and all of our VLANs are in that instance. So every single VLAN would be in instance 0. But we're going to put our VLANs, okay, so do show VLAN. We're going to put VLANs 2, 3, 4, and 5 in instance 1, and then we're going to put the rest in instance 2. So we have to start by doing spanning tree MST config. If I can type correctly, spanning tree. You got to spell it correctly. Spanning tree MST configuration. All right. You'll notice we get a new mode, and that is this config-MST. So MST sub configuration mode. We're going to set our region name, and I'm just going to say name, and we'll just call this lab. All right. I'm going to take instance 1, and I'm going to put VLAN 1 through 5. Okay. Instance 2, VLAN 10, 20, 30, 40, 100, and 200. Okay. And then you do have to give it a revision number. So let's do revision 1 on this. Oops, got to type again, type revision correctly. All right. And that kind of basically gives it a revision number to compare with other switches in the environment. So we got to go and do the same thing on all the other switches. So let's go over here, spanning tree MST config. We're going to do name lab instance 1, VLAN 1 through 5, instance 2, VLAN 10, 20, 30, 40, 100, 200. Revision 1. Okay. We'll go to D2 and do the same. Instance 2, not 3, 2, 40. Revision 1. All right, let's drop out of here on all these and actually drop out. Make sure we drop all the way out of all this config. So now what we should be able to do now is do a show spanning tree, and you will see that MST0, all right, is there. You'll see MST1, and you'll see MST2. And if we do a show spanning tree MST1 detail. You'll see now that this is all the details of the VLANs. In MST1, we have VLANs 1 through 5 mapped. We do this for MST2, which would be instance 2. You'll see that we have VLANs 10, 20, 30, 40, and 100, 200 mapped. And if you do show the same thing and do MST0, you'll see that the rest of the VLANs are mapped into MST0. All right. If you do a show spanning tree, well, just show spanning tree, you can see who the root is for each one of these. So MST1, you'll see that the root bridge is not this particular switch. Let's go over and look over here. Show spanning tree. For MST1, this is not the root bridge. So in this, we should see that this is the root bridge. This bridge is the root for MST0, MST1, and MST2. And then just like we do with normal spanning tree, let's imagine we want D1 to be the root for MST0 and 1, and we want D2 to be the root for MST2. What we would do, and the backup in case MST1 goes off, we go to config T, we go spanning tree, MST1, actually 0 root secondary, MST1 root secondary. And we could also change the actual priority if we wanted to below 32,769. But now we're going to make it root. Let's do this. Spanning tree, MST2 root primary. Okay, Control Z. We'll go back to D1. On D1, we're going to break out config T, spanning tree, MST0 root primary, spanning tree 1 root primary, and then 2, oops, we'll do spanning tree MST2 root secondary. So no different than we did before. Now if we do a show spanning tree, hopefully we'll see that we are the root for MST1, and we should have been the root for MST0, which we are, which before it was D2 was the root. But you'll notice we're not the root for MST2. Go back to spanning tree here and do a show spanning tree. You will see that we're not the root for MST0 here, not the root for MST1, but we are indeed the root for MST2. One of the things to remember about spanning tree, and this is how I teach my students to remember this, and this is the last thing I'll teach you today. Someone walked up to you. This is for all spanning tree elections, and any type of trying to figure out what something's going to take over a role. Here's the question. Someone walks up to you and says, you must jump off a bridge or you're going to die. Okay. What would you do? I'd find me a bridge that's like 2 inches high, the lowest possible bridge I could find to jump off of. Same thing is true for all elections in spanning tree. Lower is better. So lower priority, lower port numbers, everything in spanning tree, lower is better. That's how you can remember that. You got to jump off a bridge. Well, find the lowest bridge you could find. And the reason I say bridge is because switches are just bridges. Questions about that? Which, by the way, after all that, CML is working now. So I'll show this to you next week. I'll show you here what it is and how we can use it. But I'll show you that next week. All right. Any questions? Any questions on anything we went over today? Because we went over a lot.
You were saying something about an educational version of CML?
Yes. Let me pull you up the CML, well, there's two different types. There's CML personal and CML education. CML personal, again, costs you $200. CML education, I'm not going to say how much it is. Hold on a minute. I'll talk to you a little bit about it when we're not recording. So, but this is CML personal. They do also have CML personal plus, which lets you do more items. If it's personal, you can only do 20 items at a time. Cisco modeling labs, though, does have the ability to do educational version, and that one's much more. Let's do this. CML for education. CML for education. Okay, and it doesn't want to find it. So let's go to the Holy Google. CML for education. This is something that just recently came out. There it is. So here's they've got a little item on it here. I'll be showing it to you during our April is ASC month. I'll be going through a bunch of stuff in it and showing you things you can do with it. So we're going to be doing more with it. And again, I'm going to give you all access to it as soon as we get our license in and get it up and running. So, but it's a really neat tool. Again, you can see here that one of the things it's got ASAs in it. It's got these little Ubuntu boxes, so you can actually put boxes in. And you do have the ability to actually bring in your own clients. So you can actually bring in your own items. I haven't brought one in because it takes a QCal, and I just hadn't converted a Windows box to a QCal. But it has sample labs. It has just all kind of neat things in it that we can do. But here's a node and image definition, so you can actually bring in a new image if you want to. We've been using this Alpine as the desktop, but there's a WAN emulator. Okay, so there's ability to do a WAN emulator. So there's all kind of neat things that are in this that I haven't even played with. Like I said, I haven't played with this WAN emulator at all, so I don't really know what the WAN emulator can do. But it's I have built every single CCNP lab. I have a YAML file for that you can pull up inside of here. And that file, let's see if I can find one that I've got. So for instance, let's say you were doing, yeah, I've got it right here. Let me actually pull this lab down. We say you're wanting to do lab 513. So watch this. We can actually do this. I can go to the dashboard. I can go import. Oops. It brought in. I can go over here to my personal YAML files. There's 513. I can import it, go to lab, and this is a built out YAML file from previous class I did, and it's actually built so that you could do lab 513 that we have. The only thing I don't like about it is for some reason it didn't bring in the names on the interfaces, which is something new in the newest version. They actually were putting the names on the interfaces, which was very nice. I don't know why it's not showing up. Must be an option I need to do. Oh, there it is. So you just got to turn it on. So you go in here and you can just turn on the names, and it tells you what the interfaces are, so you know what's connected. So, but it's a neat tool. It really is. It's a cool tool that we'll be able to use, especially as we move further down the line. That may have been what was wrong, is I had that one running also. So probably just not enough resources on my machine to run it all. All right. Okay, I'm gonna stop recording.